Hey folks, Papa Dave, David Deliver Space. Yeah, we're back tonight. Our second launch tonight got delayed again. That's the Vandenberg launch of the Starlink satellites. But the launch for this morning, the big news, is that of the SpaceX Falcon 9 Block 5 that's going to be carrying the Nova C mission. That mission is a NASA-sponsored mission. There's 6 landers, 6 packages, one of which being a lander, that's going to be going to the moon. Scheduled T0 time is coming up here in about 40 minutes. We're at T-minus 40 minutes for right now. It is now, let's see, in Central Florida, we're at about 12:25 a.m. and we are still looking at a T machines. And again, this is a number of packages to utilize for a moon mission, which we were hoping for a 3-launch night. With that was the U.S. Air Force classified times before we can get that in the air. So what we'll do here, very fortunate to be able to have the opportunity to see this footage and see the amount of video that they provide to us. Like I always kind of fall back as a child of the Apollo days. We were very happy to see what we saw, and it was nowhere near the views we get of the spacecraft, the separation, in this case, at one point, the payload that'll be released. But other than that, we'll cut over to SpaceX for now and let y'all listen in as we come up on T0 in about 38 minutes, assuming everything holds for us.
With the pointed nose at the very top of the rocket is the payload fairing, and it's composed of 2 halves made up of carbon composite material that come together to protect the payload until we're in the vacuum of space. And speaking of the payload, the Nova C lunar lander arrived at Kennedy Space Center in Florida back in December. Since then, teams have been integrating the spacecraft to Falcon 9's second stage in preparation for launch. And as Megan mentioned earlier, during this mission, SpaceX proved out new procedures and hardware that enabled fueling of the IM-1 lander on the pad with cryogenic methane and oxygen starting about 2.5 hours before launch. This is a first for SpaceX. SpaceX teams modified Launch Complex 39A's pad and transporter erector, installing a new liquid oxygen tank, methane tank, propellant lines, and 2 control skids on either side of the top of the transporter erector. From there, the new propellant lines pass through a new Stage 2 quick disconnect that attaches to new plumbing and another set of quick disconnects leading to the IM-1 lander. Heat exchangers within the ground system densify the oxygen and methane as they flow from their storage tanks towards the lander.
Falcon 9 tanks are venting for the start of propellant load.
Falcon 9
the
is
LD
being loaded
briefing
for
the
launch.
abort instructions for non-urgent no-go conditions. Of the operation, operator shall call hold.
USS Enterprise bridge. Starting now, we have 3 primary flight controller teams on a direct shot at the moon.
That trajectory is basically like throwing a fastball that is going to hit the moon 6 or 7.
Liquid methane and liquid oxygen engine to make small course adjustments to hit its orbit target around the moon. This particular.
You can think about the B-plane kind of like the backboard of a basketball ball. And you basically know when you shoot hoops that if you can get the basketball in the square on that backboard, it's going to go in. And the B-plane for astrodynamicists is very much the same thing.
With the B-plane on target, Odysseus is prepped for a critical autonomous maneuver on the moon's with the moon blocking communications back to Nova Control information to the lander's navigation algorithms, which provide communications back to Nova Control information to the lander's navigation algorithms, which provide guidance that senses rotation and acceleration. Flight controllers expect about it for confirm.
So you've heard ahead of time to lay the foundation for human exploration. To make this happen, NASA is helping establish a commercial lunar economy. For the first time ever, there will be commercial delivery services to the moon. We are enabling American companies to send our payloads to the lunar surface for us. These delivery services will expand our capabilities for exploration, radically increasing the amount of science we can achieve. This high-risk, high-reward initiative will invest in and leverage the entrepreneurial spirit of American innovation to launch a commercial lunar marketplace, advancing technology and exploration for all of us. With this never-before-seen streamlined access to the moon, we will be able to make novel measurements and develop technologies that scientists have long wanted to do on the lunar surface. And as this new industry matures, this commercial delivery service for NASA and other customers could expand beyond the moon to other destinations in our solar system. And we can learn to live on another world because we
at the Houston Spaceport, just down the street from NASA's Johnson Space Center.
In oil and gas, and energy, medicine, and for the first time in 52 years.
So we've been talking about your lander, obviously, Nova-C, and your fellow co-founder, Dr. T.
That was a liquid oxygen, liquid methane lander that actually we flew 37 times, and we learned about how to fly a liquid oxygen, liquid methane engine. That core technology is the core technology of our Nova-C lander. In addition, the autonomous landing and hazard avoidance technology on board Morpheus, while it was older technology, those algorithms are the same kinds of algorithms we use for our hazard detection and avoidance, which is what we do on the moon to land on a place as rocky and craggy as the South Pole. And so we use that technology also, which is a derivative of what NASA produced, but we had in our know-how as we started the company.
And so you're talking about landing. You know, there have been a number of attempts to land on the moon recently, you know, by companies and other countries. Roughly half has succeeded, half have failed. So what has your company done to increase the chances of landing on the moon?
Well, I think first and foremost, what you have to do is you have to be humble about it, and you have to learn from and stand on the shoulders of all those who have gone before. So we looked really hard at every mission that has gone to the moon, and we looked for what mistakes or things in their design that caused their errors, and did those mistakes or did those design deficiencies, are they in our lander? And so we learned from others, and so we appreciate everyone who's tried to go before. But in addition, we bring things together quickly. We bring hardware and software together in the early stages of development testing and test often. And we put them on multiple test beds and test like we fly. And that's the key to success, and that's what I think we did. We learned from human spaceflight engineering to take the best of what we had and what we were doing and then streamline it to be agile and efficient. And we were working on a fixed price budget, so it was essential that we innovated. And I think over-constrained schedule and an incredibly challenging thing like landing on the moon.
The moon, there are 6 instruments on board that will play a key role in navigating. And the first one is this. It's a lightweight laser retroreflector array, or LRA. This passive optical instrument is a collection of 8, as you can see here, about half-inch reflectors or mirrors used for measuring distance. So the plan is, after Nova-C lands on the moon, future landers or spacecraft flying near Nova-C's lunar location can cast a laser towards the surface, and these retroreflectors will bounce the light back to the approaching craft. That reflected laser light will help determine how close the spacecraft are to the lunar surface, ensuring a smoother landing. So really, it's similar to when you're reversing your car and watching a camera to let you know just how close you are to an object. All right, so for more than, so let's go back now to Houston, where Josh Marshall is standing by live at Intuitive Machines with an update. And Josh, what is the latest?
Thanks, Megan. And if you're just joining us at home, welcome to Nova Control in Houston, Texas. Right now, flight controllers are monitoring launch pad activity and staying in communication with SpaceX's launch control in Florida, where we have another team working side by side with SpaceX to monitor Nova-C's fueling and launch readiness. After launch, flight controllers working each of Nova Control's 12 positions will prepare for first contact with our Nova-C class lunar lander. That process won't start until a spring force gently pushes the lander away from the launch vehicle's second stage, which is scheduled for about 48 minutes after liftoff. After separation, our lander's orbit is called trans-lunar orbit. This enables Nova-C to reach lunar orbit in about a week, but requires a lunar lander with a very capable engine. Nova-C was tailor-made for NASA's CLPS initiative and supporting commercial lunar exploration. It's a pillar of Intuitive Machines' lunar access services, and we took a deep dive into what makes Nova-C qualified for this historic undertaking.
The Nova-C was our version of a liquid oxygen, liquid methane lander, and we went about imagining that into existence.
Intuitive Machines' Nova-C class 3D printed engine took its first breath of liquid methane and liquid oxygen in 2018 on an airstrip at Ellington Airport in Houston, Texas.
We didn't have enough money for a facility with blast walls and water suppression or water deluge. So we had to test outside in the environment of Houston, where the temperature is about 100 degrees and the humidity is like the same. And we have an 18-hour day rolling out to the runway. It was brutal, but we did it to get the critical test engine data we needed to build our own engine.
Designed, manufactured, and controlled in space by Intuitive Machines, Nova-C's structure is primarily carbon composite.
We needed to build the lightest weight structure we could. That meant honeycomb aluminum core with composite face sheets, composite struts, and most importantly, linerless composite propellant tank. Man, what a challenge that was.
Between the engine, carbon composites, software, and electronics required to build a Nova-C lunar lander, it took an incredible amount of touch labor to get to the launch pad.
We worked very closely with San Jacinto Community College to create a certification course for technicians, where they would take these certifications. We then, in Intuitive Machines, would give them an internship and test them out in the workplace. And anyone that showed the aptitude to be a really good technician, we hired on the spot.
Nearly all of the lunar lander's payloads are mounted to its exterior, including 6 NASA-provided payloads that will help lay the foundation for Artemis missions. Embry-Riddle Aeronautical University's EagleCam, designed to deploy off Nova-C right before landing to take third-person perspective images. The International Lunar Observatory Association's camera system, mounted at exact angles that could capture images of the Milky Way from the lunar surface. A data center technology demonstration by Lone Star Data Holdings and Omni Heat Infinity, Columbia Sportswear's thermal reflective insulation used in many of their outdoor products, will help protect Nova-C from extreme temperatures in space.
They've got brilliant ideas, and if we can help facilitate those startups to help build this economy, I think that raises all boats. And it's as serving as the transportation leg to the moon, we're happy to accommodate those kinds of companies.
The IM-1 landing site is called Malapert A. It's named after 17th century Belgian astronomer Charles Malapert and is expectedly made of lunar highland material, similar to the material studied during Apollo 16, which was also launched from Launch Complex 39A, where we have more from Megan. Megan.
All right, thanks, Josh. And actually not far from the Malapert A landing site is the Malapert Massif region, and that is one of the 13 candidate regions being considered for the Artemis 3 landing. Okay, so a second NASA instrument on board the Nova-C lander is NASA's Radio Frequency Mass Gauge, or RFMG. The instrument is essentially a fuel gauge to estimate the amount of propellant in spacecraft tanks in specifically a low-gravity space environment. So during this mission, RFMG will estimate the amount of propellants in Nova-C's tanks. Once proven, RFMG technology would demonstrate significantly more accurate measurements of a fuel tank's fill level without requiring a thrust to provide a force upon the fuel in order to measure it, as current technology does. For the first time in more than 50 years, astronauts, including the first woman and person of color, will travel to the moon as part of NASA's Artemis program. To get there, SpaceX and NASA teamed up to develop the human landing system. Here's a closer look at your Artemis Moon Minute.
With Artemis 3 planning to return humans to the moon for the first time since 1972, NASA and its commercial partners continue to develop the systems needed to land crews safely on the lunar surface. SpaceX will provide and operate a moon lander for NASA's Artemis 3 mission called Starship Human Landing System, or HLS. During Artemis 3, NASA's Space Launch System rocket will launch 4 astronauts aboard the Orion spacecraft for their multi-day journey to lunar orbit. The Starship HLS, powered by 2 variants of SpaceX's Raptor engines, will launch uncrewed on a super heavy booster to lunar orbit to pick up the crew. Once on board the HLS, 2 crew members will head to the surface of the moon, where they will live and work for about a week, collecting samples and performing science experiments. Once they're done, they'll get back into Starship to the orbiting Orion and return to Earth. That's your Artemis Moon Minute.
All right, folks, we are at T-minus 17 minutes and 24 seconds at this point. Just one thing I wanted to bring up, the design of the Intuitive Machines control room is amazing. I did not know that until I saw that on the broadcast. They said it was modeled after the Starship Enterprise's bridge in a circular design, as opposed to what you normally see at Mission Control, which is console after console one behind another. With that circular design, the center core table allows a lot more interaction between the control people, and but I just think it looks really cool. Harkens back again to the age of Star Trek, but everything looks good right now. The feeds are showing everything is good. As you heard earlier, they are taking a different approach to the fuel loading right now. They made some design changes to the pad that accommodates all of this. Normally fuel would not be loaded as early as it was, but at this point everything is looking good. Everything's nominal. We're at 16 minutes and counting, and we'll just flip back over to the commentary. Again, thank you to SpaceX, thank you to Intuitive Machines and NASA, of course, for providing all the video and detail through their feed, through the NASA feed. It's always a great thing to be able to show this and share it with the public, and it's the reason why we're here. So we kick back over here for what we hope is the last 15 minutes before an on-time T0.
SpaceX will perform one uncrewed demonstration flight before the Artemis 3 mission, which will be the first human surface expedition since 1972. To that end, SpaceX has been hard at work getting Starship ready for its moon missions and ultimately Mars. There's so much to look forward to, and it's just incredible that humans are finally going back to the moon, and the efforts of SpaceX and Intuitive Machines get to play a vital role in that. IM-1 mission. Let's check back in with Josh at Intuitive Machines.
Down the minutes to launch and looking forward to Intuitive Machines firing its Nova C-class lunar landers. Engineers at NASA's Johnson Space Center used to integrate technologies for future spacecraft that could land on a variety of destinations. Autonomous landing and hazard avoidance technology designed to enable a spacecraft to identify, descend, and find a safe shuttle and landing facility. Now is our co-founder and Chief Technology Officer, Dr. Tim Crane. With your fellow co-founders, Steve Altimus and Dr. Cam Ghaffarian, you were working on other things at Johnson Space Center to include Project Morpheus. What can you tell me about Project Morpheus led to us getting to the launch pad today with your company?
Well, one thing I can tell you is it takes me right back, but this is a journey that clearly our prop technology was a big part of Morpheus we brought forward. Also, the all-hat, the autonomous landing, hazard avoidance. Test our systems, and even the discipline about knowing when some technology needs to wait for a future date so we can get to flight. all of that came from the Morpheus experience.
And, you know, just about a year ago, you got to see those Project Morpheus tanks again, but this time they were in your facility and you were testing them with your company. What can you tell me about speeding up innovation through NASA's Reimbursable Space Act agreement?
Well, NASA really is a national treasure in terms of knowledge and capability, and in some places, equipment. And we had a supply chain issue with some of our tanks, and we needed to get our test rig up and running. And we knew the Morpheus tanks were in surplus, and reached out to NASA, and they facilitated getting those tanks to us so that we could proceed with testing while our flight tanks were coming in.
And real quick, while you have you, why liquid methane? Why liquid oxygen?
Well, in the near term, it's very easy to work with. It's environmentally friendly. It's non-toxic. It's very robust to changing conditions. Down the road, it's the exploration fuel of the solar system, and we can make it on Mars for bringing spacecraft back from there, so we don't have to take all the fuel with us.
Well, Tim, I know you're burning back to get back into mission control, watching your team that you fostered throughout all these years and listening to that IM-1 mission loop. We do appreciate your time today, and thanks for stopping in.
Thanks, Josh.
NASA instrument on the Nova-C lander for this IM-1 mission is the Lunar Node 1 navigation demonstrator, also called LN1. That's much simpler. It's similar to when you use GPS to get to a destination. Let's take a look at how it works and what it will do to help support future surface and orbital operations.
Lunar Node 1 is meant to be a demonstration of how we can use various navigation technologies to figure out where you are in and around the moon. I'm holding in my hands the Lunar Node 1 mass simulator. We use this build to test out our vibrational modes, put on a shake table, and also do fit checks with the lander itself. Inside of our payload, we have multiple electronics boards that fit within this chassis that is a little bit about a half U in size. You can see our external connectors here where we have our data and power to the lander itself. And within here, we have multiple boards that do the power regulation, our data control, our FPGAs, all those kind of electronics pieces are in here, as well as a small S-band radio that attaches up underneath this top radiator in order to distribute this heat, and then to talk to the antenna, which mounts here. This is the same size and build as the flight payload. It's just not covered in MLI or some of the other materials that you'll see on the flight build itself.
Now, IM-1 is the second launch of a lunar lander under NASA's Commercial Lunar Payload Services Initiative. The first CLPS launch was with Pittsburgh-based Astrobotic. The mission was called Peregrine Mission 1. It successfully launched last month on a ULA rocket, but afterwards, Astrobotic reported a failure in its propulsion system, which prevented the spacecraft from landing on the moon. 10 days later, Peregrine burned up after re-entering Earth's atmosphere. An anomaly review board will release its findings to what happened once complete. Joining me now to talk about NASA's CLPS initiative and its benefits and risks is Sandra Connolly. She's the Deputy Associate Administrator for NASA Science. Good morning to you.
Good morning, Megan.
So talk to me about some of the key takeaways as NASA moves forward with commercial lunar vendors.
Yeah, so the Commercial Lunar Payload Services Program is super important to NASA. It really is transforming our method of doing business. It's leveraging industry's emerging capabilities of actually providing end-to-end service for us. So rather than us having to build our own, we can now procure it. And it's not only, we're not the only customer. Other government organizations, industry, academia from around the world are all going to procure these services. And there is risk associated with it, though. So we recognize that as we're evolving this capability.
Yeah, so I was just going to ask you that. I mean, because we know that there are risks, and
Spacecraft
we've accepted
is go for
those
launch.
risks. Spacecraft is go for launch. We just heard a call for that. What involvement does NASA have when our commercial providers are assessing the risks?
So what's really important about this, too, is recognizing that industry is in the lead in providing these services, so they're the decision makers. So ultimately, what will happen is, you know, as they're making their decisions, we obviously bring great experience along with us, and we will stand shoulder to shoulder with them and support them through the legal process, through contracts and all, but we will bring to bear what we need to support them to make sure that this is successful.
Sure. So it seems like, again, yes, we're fully committed to the CLPS initiative. So what is NASA sending to the moon on future CLPS flights?
So again, super exciting time for NASA. You may or may not realize we have 40 manifested payloads on the CLPS mission. So over the next few years, and that's just for the NASA payloads, right? So you've got industry and academia as well. But focusing on Intuitive Machines, which is our purpose for being here tonight. We're super excited about their efforts here. So they actually have another payload that's going to be launching later this year. They're going to be delivering the Prime 1 drill and spectrometer, which is actually going to support our in situ resource utilization and support a future human presence on the moon.
Sandra, thank you so much. We're excited to see what CLPS can do for NASA and for humanity, really, with what we plan to do with the Artemis program.
Thank you.
Thank you so much.
Go Falcon 9.
That's right.
And go IM-1.
Perfect. All right, so let's send it back to our friends at SpaceX in Hawthorne, California, as they walk us through the final moments of the countdown, and then I will see you guys after launch.
Awesome. Thank you so much, Megan. At T-minus just under 7.5 minutes, all systems are currently a go for an on-time liftoff. Next up, in just about a couple minutes, the structure next to the vehicle, known as the strong back, will begin to retract away from the vehicle. But while we wait for that, let's talk about what it takes to actually get to orbit. In order to get the rocket and payload into any orbit, the rocket not only has to go up really fast, but it also has to go sideways.
Engine chill has started.
As we ascend, we tilt the engines, and that turns the rocket horizontally. To help demonstrate this concept, an image of a firing cannon from a really high mountain is what you can see there on your screen. The cannonball will arc, and then good old gravity will pull it back down to Earth. As you increase the power, the cannonball will arc and land farther and farther away. Eventually, if you could continue to increase the power, the cannonball will end up in free fall around the Earth. Basically, gravity is pulling down on the cannonball, but it's going so fast that it never hits the ground.
RP1 load is complete.
This arc that constantly misses the Earth is called an orbit. Falcon 9 effectively does the same thing as the cannon in this example, and it provides enough power and horizontal velocity to the second stage carrying the spacecraft, enabling the spacecraft to be placed into orbit around the Earth. Now, you'll be able to see this today by watching the orientation of Falcon 9 after liftoff. The rocket will go straight up until about T plus 10 seconds, at which point we will begin that shift in orientation, gimbaling the engines so that Falcon 9 can go horizontally really fast. So be sure to look out for that after liftoff. Now again, at T-minus 5 minutes and 38 seconds, all systems are currently go for liftoff. The strong back is going to begin retracting away shortly in preparation for that retraction. The clamp arms, which are located just around the second stage, just below the fairing, will begin to open. Once those are fully open, then the TE, or the strong back, can begin to recline away from Falcon 9. And you can see that on your screen, those clamp arms just below the fairing there. Now, the vehicle is nearly fully loaded with propellants, and we did hear a call out that stage 1 prop loading has concluded. We are still loading blocks. And there's that call out that we are beginning that process for that strong back retraction. Propellant loading is continuing on the vehicle and will complete at T-minus 2 minutes. The range is currently green and ready to support liftoff. And if for some reason we do not launch today, we do have a backup opportunity on Friday, February 16th at 1:12 a.m. Eastern Time.
Strong back.
All right, folks, at T-minus 4 minutes and 23 seconds, we are go. There's going to be some final polling being done before the final go-ahead is given by the launch director. But right now they're retracting the strong back. Fueling continues to be in process and will be for about another 2 minutes. At that point, we will be topping off. They'll be clearing the lines. At 1 minute, the internal computers will take over the launch. Falcon 9 will be responsible for the launch and will be controlling the launch, with the exception, of course, anything that is found or seen on the ground. Ground always has final say to stop a launch. But at that point, the internal computers and systems take over the launch, and we'll control it from there. And at T-minus 3.5 minutes, everything still looks green. We're nominal across the board. Weather's good. I believe the last percentage was 95% go. So we don't see anything right now on the board that looks adverse at all. So at this point, like I said, they'll be topping off the tanks here in the next minute, clearing those lines and preparing for hopefully an on-time launch in about 3 minutes. And we'll take you for that last 3 minutes, and we'll enjoy this together.
It has a
Stage
much
1 launch load is complete.
A much greater amount of mass per volume, allowing us to load more of it into the vehicle. And in addition to these two propellants, we also use the chemical TTAB, or triethyl aluminum and triethyl borane, as an ignition source. The combustion of RP1 and liquid oxygen is what makes the rocket go, but it's the TTAB that sets the match to the propellant mix. And we did hear a call out that stage 1 liquid oxygen loading is complete. Coming up next, it's at T-minus 60 seconds. Falcon 9 will go into startup. That means that the rocket's autonomous flight computers will have taken over the launch countdown. And at just inside T-minus 2 seconds, we will light those Merlin 1D engines for liftoff. The Intuitive Machines payload continues to be healthy, and the Falcon 9 team is tracking no issues on the vehicle. We are currently green for weather, and the range is ready to support a T0 of 1:05 a.m. Eastern Time. And just waiting for the call out
Stage 2
for
LOX load is
liquid
complete.
oxygen. Right on time. Stage 2 liquid oxygen loading is now complete. That concludes propellant loading on the vehicle. That means that Falcon 9 is fully loaded with 1 million pounds of kerosene fuel and liquid oxygen. Weather is 90% chance of
ground gas closeout.
Good weather for T0. And we are just about 30 seconds away from Falcon 9 going into startup. Now that propellant loading is complete, we are beginning to vent out the lines, the propellant lines on that transporter rector there, so you can see more of those white clouds around the vehicle. Startup is coming up here in a couple seconds.
Falcon 9 is in startup.
Great call out. That means that the internal flight computers have now taken over the launch countdown. We are now just waiting the final go from the launch director.
LD, go for launch.
An excellent call. All systems are go for launch of Falcon 9 with the Intuitive Machines lunar payload.
All right,
30 seconds.
Less than 30 seconds to go. We have a final go from the flight director. And we should be ready to get this off the ground.
$15 seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. And liftoff. Go SpaceX, go IM-1 and the Odysseus lunar lander.
And we have liftoff. On time at 1:05 Eastern Time here in Florida.
Falcon 9 has successfully lifted off from Pad 39A at Kennedy Space Center, carrying the IM-1 payload. Now, during ascent, we tilt the engines, the technical term being gimbaling, and that turns the rocket horizontally. And
Mach 1.
All right. And Falcon 9 is heading downrange at this point. As they were speaking about the gimbaling of the engines earlier, they actually will move and steer the rocket as it heads downrange.
Yep. We have a few events coming up in quick succession here. That will be MECO, stage separation, SES-1, and then the boost back burn startup on the first stage vehicle. MECO, or main engine cutoff, is where we shut down all 9 of those M1D engines on the first stage vehicle. That helps slow the vehicle down in preparation for stage separation, which is where the first and second stage will separate. And the first stage booster will begin its trip back to Earth. And the second stage vehicle will ignite that MVAC engine with SES-1, or second stage engine startup 1. And then the boost back burn will begin on the first stage vehicle, which is one of 3 burns that's required for the vehicle to make its way back to today's landing zone. And this burn assists with the vehicle to reorient itself back towards land.
Stage separation confirmed.
And there's stage separation. Beautiful shot up the barrel of stage 1.
Stage 1, boost back startup.
Stage 2 ignites, and the boost back burn has started,
saw and heard those call-outs,
which will
from
reorient
MECO,
stage 1
separation,
for its trip back
SES-1
to LZ1.
and the boost back burn startup on the first stage. Some great views there. Now the first stage is currently performing its boost back burn. This is where we ignite a few of the engines to bring the trajectory towards the landing site. And coming up here shortly will be fairing separation.
Fairing separation confirmed.
There we go. Beautiful shot. And there's the lander.
And an excellent view of fairing separation and an amazing view of the IM-1 payload attached to Falcon 9's second stage. Fairing deployment has been confirmed. And we will be attempting to retrieve these fairing halves once they fall back to Earth with our recovery vessel, Bob.
And each of those fairing halves is about $3 million savings for SpaceX.
And some good call-outs there.
All these factors contributing to the ability to rapidly reuse.
There will be a couple more burns on our first stage to prepare for landing at landing zone 1 at Cape Canaveral. Again, we've completed the boost back burn on the first stage. That's the first burn of 3. The next burns coming up will be the entry burn and then the landing burn for the first stage vehicle. Now we are at T plus 4 minutes and 17 seconds into today's mission. IM-1 is SpaceX's 14th launch this year, and the lunar lander on board could be the first U.S. moon landing since the Apollo program ended more than 50 years ago.
Way too long and way
exciting. The MVAC
exciting.
engine on the second stage is ignited, and we are currently in the first of 2 planned MVAC burns. Around T plus 6 minutes, you should see on your screen the first stage's entry burn coming up on that first stage vehicle. Again, that is the second of 3 burns. For the entry burn, we will relight 3 of those M1D engines, starting with the center E9 engine, followed shortly afterwards with the E1 and E5 engines. This helps slow the vehicle down as it enters back into the Earth's atmosphere. Now we need to slow down the vehicle to reduce re-entry forces, and that helps us to recover and reuse the first stage.
Now the payload on this, just as a side note, just under 2,000 pounds.
Is a view of the MVAC engine on the second stage. And you can follow
So I guess that's about the size of a smaller vehicle.
Speed and altitude of both vehicles on the bottom left hand of your screen. That is showing the stage 1 telemetry and stage 2 telemetry on your right hand screen.
And also, as a side note, the landing is scheduled to take place Thursday, the 22nd of the lander. We'll try to carry that also live.
And what you're seeing on your screen on the left-hand side, it's a little dark there, but that is a view from the first stage. And with the entry burn, we should see that screen light up with the engines reignited.
You can see the coast of Florida coming up there, the lights of Florida, Space Coast. All right, that's entry burn. That's 3 of the engines lighting.
Entry burn has begun with those engines relit.
You'll see very quickly the altitude drop along with the speed.
Stage 1 FTS.
And a very quick
Both
entry
vehicles
burn
are on nominal
there.
trajectories.
Great call-outs, both vehicles on nominal trajectories. And as I mentioned, that was the second of 3 burns required for this booster to return back down to land. The next and final burn will be the landing burn. That's just a center E9 engine burn, and that helps slow the vehicle down just in time for landing. That's coming up in just about 15 seconds or so.
Speed's reducing rapidly. The grid fins are in control of really causing the aerodynamic point at which the stage 1 will be able to get to LZ1.
Stage 1, left burn.
And we're coming up on landing. Landing burn.
And there you can see on your left-hand screen the landing burn has begun. Let's watch as Falcon 9. Let's watch as Falcon 9 touches down for landing.
And another great landing.
And a great view there. That is, we just had confirmation.
We're waiting on confirmation of landing. Cut out pretty quick.
SECO-1 as well as a confirmation of good orbit for our Falcon 9 second stage carrying our IM-1 orbital class rocket, including first stage landings for Falcon 9 and Falcon Heavy. And engine or SES-2 on board the second stage around the T+41 minute mark, followed by spacecraft separation. So until then, we're going to send it over to Megan at K.
All right, folks, I just see we have landing of stage 1, Falcon 9's 300th mission. A little bit worrisome whenever the feed cuts that way. You get a little bit worried about it, but everything seemed to go well, and now we're just waiting for the next burn of stage 2. We can boost that orbit a little bit and then wait for the point at which they'll release the payload and send it on its way. That won't be for a bit, but we do have a good orbit. We do have a good landing. We'll just stand by, and it looks like the altitude is stabilized, that the burn got them where they needed to be. So we'll just stand by and take a listen to the broadcast coming out of NASA.
Lunar surface for this mission and future ones.
SCLPS is an array of small cameras that will be placed around the base of a lunar lander and collect imagery during the descent and landing of the vehicle. Using a technique called stereophotogrammetry, we can use those images to reconstruct a 3D shape of the ground. As the lander comes down, its hot engine plumes will interact with the surface. Our cameras will begin acquiring images from before this interaction begins until after the vehicle has landed on the surface. The SCLPS cameras will specifically be looking at the overall crater formation and erosion of the ground due to the rocket plumes. The final stereo images, which will be stored on a small onboard data storage unit, will be transferred to the lander and then downlinked to Earth, where we can use them to reconstruct the overall erosion volume and shape of the ground. With the Artemis program, we plan to establish a sustained lunar exploration and try to land multiple payloads in close proximity to one another. SCLPS data will be a critical part of understanding these phenomena and improving our computational models to inform these future landings.
Let's head back now to Houston, where Josh Marshall is standing at Intuitive Machines headquarters with an update, and I'm sure very excited as well, Josh.
Thanks, Megan. With each passing minute, we are closer to receiving the lander's data in Nova Control. Right now, flight controllers are standing by for launch vehicle separation, followed by acquisition of signal. That's when the lander makes first communications contact, sending critical health and flight data into Nova Control. And we want to bring you closer to our Mission Operations Center to experience a few types of information that flight controllers are looking at during the mission. This particular screen is called the Deorbit Descent and Landing, or DDL screen. This screen is primarily used by the mission director and landing system experts. It's used primarily while Nova-C orbits the moon and through landing. The top right images of the moon are called the lunar tactical view. When the dots turn red, the lander is on the far side of the moon, and green is on the near side. The line is the tail where Nova-C is, with each dot representing 10 minutes of elapsed time. The acceleration sensed portion of the screen shows raw acceleration values from Nova-C's inertial measurement unit. This is used a lot during burn maneuvers and is a more robust way of measuring acceleration over time, with the ability to look back at what has happened. For some reason, flight controllers have lost data. Finally, the column on the right is a received, accepted, edited, and failed pre-checked, or RAFE chart for short. When each of these lines are on top of each other, that's a good indication that Nova-C's navigation system is in good health. That's because every measurement Nova-C makes must be received, accepted, edited, or failed pre-check. The failure is a possible outlier of data that the lander's computer automatically knows is bad information. Collectively, the DDL screen is one of many data displays that flight controllers are monitoring to successfully navigate Nova-C to the lunar surface. It's no small feat, and the tireless effort of our entire Intuitive Machines team has brought us to this moment, standing by for launch vehicle separation and acquisition of signal in approximately 40 minutes. Until then, we'll toss back to Megan with more on the challenges that lie ahead of the IM-1 mission.
Yeah, we've been honest about it. You know how difficult it is to get to the moon. We haven't done it in more than 50 years, but the CLPS initiative is going to change that. NASA and American companies who have teamed up to explore the moon know a lot of research needs to happen before astronauts head back to the lunar surface. In the end, the rewards outweigh the risks.
Landing on the moon is...
And just one point to make, and I've made this before. This is an exciting event because Launchpad 39A has not been the takeoff point for a lunar mission since 1972. I believe it was Apollo 17. I have to check my facts though. But it has been, as she indicated, more than 50 years. And for us to finally be taking a step, as other nations do the same thing, but we are taking a step to get back to the moon, put some robotic presence there, begin the process of photographing and doing the testing that's necessary to bring multiple payloads onto the CLPS program, to begin that process where the SpaceXs and the Blue Origins and the other companies can all start utilizing the landers that they're under contract to develop to get us back to the moon. And I can recall, as a very young person, being almost 63 now, it's been a while, but I can recall the Apollo missions and the excitement, even though towards the end they say it got a little boring. I don't think it ever gets boring watching humans walk on the moon and conduct experiments and be brought safely home. And that's where we need to get back to. And it's been a long time since we've been there. We can have a discussion why. Everybody's got their own theories. It's kind of interesting that we, and I'll use the air quotes that I hate so much, that we lost the technology or lost the ability and have to reinvent the wheel. But we will get there with companies, private firms that are out now helping develop this technology. We will get there. And that'll be the stepping stone to take us further out. But this is definitely exciting for those of us who recall the Apollo missions, watching those moonshots out of Kennedy. And the history isn't lost on this moonshot. It's not a manned mission, but it is going to the moon. We hope and wish only the best for Intuitive Machines as we take these next steps. We're going to head on back. There's a lot of data coming back, and they're answering a lot of the questions people will have about the lander and the experiment package. packages that are going up there.
Tremendous benefit across the scientific and economic communities.
So there's a lot we'd like to learn about the moon to help human habitation and prepare us for missions to Mars and beyond.
So the moon is the first step.
Flying on commercial missions will mean cost savings for NASA. To talk more about that, we have Joel Kearns here now. He's the Deputy Associate Administrator for Exploration in NASA's Science Mission Directorate. It's a very good morning, Joel. We just saw launch.
Oh, beautiful launch. Fantastic. It's great to be back here, Megan.
Yeah, perfect. So, how does NASA maintain oversight when it comes to this, the CLPS vendors? Obviously, this is a new initiative for us.
Yeah. Well, remember, what we're doing here is NASA is not doing these missions. We're actually buying passage on commercial companies' missions for our experiments and our cargo. So we have established this group of pre-certified 14 U.S. companies that we can go to and have them bid to do a specific mission for us, to land at a certain place of the moon, and to bring our cargo or our experiments with it. Once we actually select a company to do that, we assign them a NASA engineer who's their liaison. They represent all the NASA cargo and payloads to the company, and they represent the company back to NASA. As part of that, we get a lot of insight into how the company is actually going to do their mission. We try to make sure they really understand what they need to do to make our cargo successful, our data come back from the moon. And then we continuously learn from that, and we feed back and make sure that all 14 of those companies are certified to be able to do this work.
So a very collaborative effort. And we're talking a lot about a commercial lunar economy. That's kind of the end goal. So how does that shape up with CLPS? How do we get there?
A couple of different aspects. When you hear us talk about wanting to form a lunar or a cislunar economy, in the short term, what that really means is encouraging the companies to get other non-NASA organizations to pay them to bring their experiments or their cargo on the moon. But it's actually a lot broader than that. Just by offering these contracts to industry and having them build their own missions that we can take a part of, the companies are developing their own, you would think of as a parts and high-tech ecosphere on Earth that's part of the lunar economy. Over the years, they've had to figure out ways to build these robotic landers. In some cases, helping other companies do new advanced high-tech components like rocket engines or fuel tanks or sensors. Now we're talking about small payloads going to the moon from commercials, work or goods or services of other bigger companies that just want to do work in space.
So what would you
successful where we go out to companies and in effect we pay for a service to get our things to the moon. It's just so every attempt that the companies make, we're always looking at. We're trying to learn from that and figure out how we're going to adjust things to go forward to do next.
The fifth NASA technology we want to dive deeper into is called ROLSYS, which stands for Radio Wave Observations at the Lunar Surface of the Photoelectron Sheath. There's going to be a quiz on that later, so I hope you all took that down. ROLSYS will use 4 antennas and a low-frequency radio receiver system to determine how nearby radio emissions from the Sun, Earth, and other planets could interact or interfere with science conducted on the moon. This experiment is something that has never been done before. It will perform many tests, including detecting solar radio bursts, radio emissions from Jupiter, and dust impacting the surface of the moon. ROLSYS could even serve as a baseline for a future radio observatory on the lunar surface. Let's get another update from Josh Marshall, who's standing by live at Intuitive Machines headquarters in Houston. Josh.
Hey Megan, when I asked our mission directors about what should I expect from launch vehicle separation on until about AOS, and they said, well, we're just going to be patiently waiting. And after 4 years of hard work to get to this point, this must feel like an eternity. Let's take a live look into Nova Control. For some of the folks working today's launch and acquisition of Signal Shift, they've been working on the IM-1 mission since before we were awarded the task order back in 2019. Even folks that started in the past couple years or the past few months have poured their hearts and minds into this IM-1 mission. In fact, every Thursday, Intuitive Machines holds a lunch and learn for folks to learn more about the company. And just a few days ago, one of our flight controllers, Brooklyn Herman, was describing today's events and said the opportunity to land on the moon has been a dream for her whole life. And everyone at Intuitive Machines is part of this beautiful mission, an incredible opportunity. And while we do have a moment just in between launch vehicle separation, we want folks at home to know that that same sentiment echoes through everyone at Intuitive Machines. We are humbled by the gravity of our mission, yet emboldened by the boundless possibilities that lie ahead, starting with acquisition of signal, which we expect to happen just a few minutes after launch vehicle separation. For now, our team will continue to patiently wait and toss it back to Florida to introduce another IM-1 mission payload. Megan?
Well said, Josh. Okay, so the sixth and final payload has 3 telescopes that will help the spacecraft land safely. In the past, astronauts had to use a viewfinder or rely on radar.
So the Artemis program has taken NASA back to the moon, and everything that goes there, including the instruments and people, must be flown there safely and landed there precisely. So the landing phase of that task is one of the most critical aspects of it. NDL is a LiDAR instrument that is used to enable that capability. It uses light in the same way that sonar uses sound. For NDL, we have 3 telescopes where light would come out of the telescope, hit the moon's surface, and some of that light will be reflected back. These telescopes are mounted on the outside of a vehicle so you get a clear view of the ground as it's coming in for a landing. In the Apollo era, large radars or astronauts using their eyes looking out of a viewport were used to help land the vehicles. NDL is going to have to take the burden off of the crew with a much smaller, lower power, and more accurate instrument.
Throughout the broadcast, we showed you each of the 6 NASA instruments that are bound for the moon. To talk more about those is NASA project scientist Deborah Needham. Good morning to you.
Good morning.
Beautiful launch.
A beautiful launch, so exciting.
So now we have 6 payloads bound for the moon. Is there a common theme among them?
I would say there are 2 themes to the payloads on board Intuitive Machines' Odysseus lander. The first is demonstrating technologies for enabling future spacecraft to land more safely and more precisely on the lunar surface. And the second is characterizing the surface of the lunar South Polar region, which is an extremely challenging environment to operate in, and it's preparing us for sending humans to the lunar surface in advance of the Artemis missions.
Mm-hmm. So very precise things they're being sent for to study. So, if they make it to the moon in 8 days, what happens next for each of them?
So even the payload's work starts even before they get to the moon. Intuitive Machines, while it's transiting towards the moon, will turn on the NASA payloads to make sure that they survived launch and are operating as we expect. And then you've heard about the RFMG, the radio frequency mass gauge. It will be operating the entire time all the way to the moon and down to the surface to make sure that it's monitoring propellants and collecting the data that it needs to achieve its missions. And then during descent, you heard about NDL, the Navigation Doppler LiDAR, and SCALPS. They're going to be operating during descent and collecting their data. And then once on the moon, Intuitive Machines will turn on our other NASA payloads and they'll take turns collecting data until they achieve their missions.
How are these instruments selected?
Early on in the CLPS initiative, NASA turned to our scientists at the NASA centers to identify science payloads and technologies that were relatively mature in their designs. We did that because we wanted the payloads to be ready for when the landers were ready to integrate them onto the landers and deliver them to the moon. So then NASA turned to the vendors and said, okay, you pick from this pre-selected list of NASA payloads which ones you think you can successfully integrate onto your landers and deliver to the moon. So Intuitive Machines actually chose the payloads that are on its delivery.
Deb, thank you so much. I can't wait to see what we discover with these payloads.
Me too. Thank you so much.
Thank you. Okay, so now we're going to step aside while we await our next big milestone, the second burn of the second stage of the Falcon 9 rocket, and then right after that, the separation of Intuitive Machines' lunar lander from that second stage. We are expecting that to happen about 20 minutes from now, so we will see you then.
ever look at a rocket from Mars and you just boggle the mind and mind and mind and mind. And the technology caught up, didn't it?
All right, folks, just want to check in, and like I said, we're at T minus T plus, so I apologize for that delay. I've got delays coming off of all my feeds. But what we're looking for next is going to be SECO, the next burn, second engine cutoff, and then separation of the lander. At that point, Innovative Machines will be looking to pick up the signal from the lander, be able to check in with it, check its health, make sure it's ready to go, and send it on its way. It's about a 1 week, almost exactly a 1 week trip. Get the details for you, but the landing is scheduled for next Thursday, the 22nd. And we are looking forward to that. Again, this is a historic launch and historic landing. Launch from the pad that serviced prior Apollo missions going to the moon, and the landing being the first United States sponsored, funded, and the beginning of the program to get human footprints back on the moon. It's very exciting, and looking forward to this landing, and there's going to be another one behind it. There's different players involved under this CLPS program. Again, CLPS is the Commercial Lunar Payload Services contract, where NASA contracts with private firms and funds them in the development of their landing vehicles and the packages, and then uses the vehicles to get their packages to the moon. And that is as opposed to the way that NASA always did things, which was develop the vehicles, develop the packages, and then they would fly and control and be responsible for the ride, so to speak, to the moon. That's where they're using SpaceX now for launch vehicles. They're using, we'll be using Blue Origin in the future. Blue Origin's also got their production moving pretty fast and furious with their moon lander version. So there's a whole lot going on. I know a lot of companies involved in this, and it makes for rapid iteration of products, of vehicles, and as Elon Musk will say, you have to experiment, you have to fly them, and if they blow up, then you correct what deficiencies were there, and then fly again. The more you can fly, the quicker you can fly, the quicker you end up with a vehicle or with a product that is usable. So we're looking forward to just what I see and what I believe we'll see over the next couple of years, into the next 5 years, is pretty amazing. And then 2025, we should have Artemis if it stays on schedule. So we have not boots on the ground at the moon, but humankind making it to the moon and orbiting it. And then in 2026, Artemis 3 is scheduled as of right now for their landing. And that will involve the partners that NASA has gotten with, SpaceX, Blue Origin, and whomever else they need to work with in the process of developing the hardware to get Americans back on the surface of the moon. So it's a very exciting time. And we're at T plus 3514 right now. And looks like we've got a little bit of a ride here until we hit the second burn seco, and then ultimately the separation of the payload. And I see nothing detrimental here. And I've got a separate feed that I'm keeping an eye on. Everything I'm hearing sounds nominal. But the big thing will be if they acquire signal and make contact with the lander itself. As you all know, the prior landing attempt, it became quite evident that there was a problem with that early on in the mission. And we are hoping this time around we can see all positives come out of this, and then have this craft begin its 1-week trip to the moon and its landing spot on the I believe it's the southern part of the moon. It's Oceanus Procularum is the location, and if I butchered that, which I probably did, I certainly do apologize. I'm not up on my Latin pronunciations, but Oceanus Procularum is what they have the location of the landing being. So we'll be standing by here at 3702 and come back when we are ready to hopefully see some more action and have that lander begin its ultimate journey. Thank you all for coming by and watching. Appreciate it. And hope you stick around till the end of the feed. Enjoy bringing it to you. If you're a subscriber, thank you so much. I absolutely do appreciate every subscriber I got. If you're not a subscriber, please, if you enjoyed, please consider subscribing. It will certainly help grow the page and get the ability for us to get out there more and bring this exciting time to more and more people. So we'll be standing by, and if there's anything new, we'll break in and bring that to you.
And welcome back to Kennedy Space Center, where we are currently awaiting the second burn of the Falcon 9 second stage and separation of Intuitive Machines' lander. This comes after a successful liftoff of the Falcon 9 rocket with the Nova-C lander called Odysseus at 1:05 a.m. Eastern Time. Intuitive Machines, an American company based in Houston, Texas, developed and built the lunar lander that is carrying, among other things, 6 NASA instruments. And if everything goes as planned, in 8 days, mark your calendars, February 22nd, that Nova-C lander is expected to land on the south side of the moon. Let's go now to SpaceX headquarters in Hawthorne, California, where Jesse Anderson is live as we await that second burn and then spacecraft separation. Jesse.
Great, thanks, Megan. Now we are about a minute and a half away from that second burn of that MVAC engine. Next coming up will be SES-2, that second stage engine start 2, and that will be followed by SECO-2, which is second stage engine cutoff. This burn will last about 53 seconds and will help the vehicle to make it to its final targeted drop-off orbit. Then the vehicle will coast for a few minutes prior to spacecraft separation. So we're getting very close, and this is getting very exciting here. Again, we're just about a minute away, just under a minute away from that last burn of this MVAC engine here. Now, right now, what you're seeing on your screen is an excellent view from the second stage, looking at our MVAC engine with the amazing view of Earth in the background there. The IM-1 lunar lander is still currently attached to Falcon 9's second stage at this moment. And again, SES-2 and SECO-2 are coming up here in just about 15 seconds or so. And hoping to be able to continue these live views here so that we can see SES-1 and SECO-2. It's about a 53-second burn, so just under a minute.
Vac has been lit.
And shutdown of this MVAC engine coming up here in just about 10 seconds or so. And there you can see
nominal orbit insertion.
The MVAC engine has shut down,
Good
and we did
news.
hear that call out for a confirmation of good orbit. So with confirmation of a good orbit, it looks like we are on track for spacecraft separation in just a few minutes from now, just about a little over 5 minutes. Now, it's been a great launch so far. SpaceX did begin fueling of the IM-1 lander on the pad about 2 hours and 20 minutes before liftoff. And we did talk about that a little bit earlier in the webcast. It's a totally new procedure and new hardware for SpaceX that enabled fueling of the IM-1 lander on the pad with cryogenic methane and oxygen. Now, to be able to do that, SpaceX teams modified Launch Complex 39A's pad and transporter erector, installing a new liquid oxygen tank, a methane tank, propellant lines, and 2 control skids on the transporter erector. Then from there, the new propellant lines pass through a new Stage 2 quick disconnect that attaches to new plumbing and another set of quick disconnects that lead to the IM-1 lander. And given the lack of methane used on the Falcon program, Falcon teams actually leaned on the expertise of Starship teams and used methane sensors from Starship to verify the health and status of had a good last and final burn of our MVAC engine. That was SES-2 and SECO-2. And now the vehicle is continuing to coast with the spacecraft attached until it reaches the correct targeted drop-off orbit. And just to recap, if you're just now joining us, we did have an on-time liftoff at 1:05 a.m. Eastern Time. And everything has been proceeding nominally. Stage separation occurred just about 2.5 minutes into flight. And that was followed by the successful landing of our Falcon 9's first stage back at Landing Zone 1, or LZ1. And that was the 18th landing for this specific booster. Now, for those of you following along, this booster has supported GPS 3, Mission 3, Turksat 5A, Transporter 2, Intelsat G33 and G34, Transporter 6, and 12 Starlink missions. So pretty impressive and veteran booster for today's mission. At about T plus 7 minutes and 46 seconds, we did have a successful second engine cutoff, or SECO-1. That was the first burn of the 2 burns for this mission, and that was followed by confirmation of good orbital insertion. The vehicle was then able to coast for a bit there, and then again, just a few minutes ago, we did have the second burn for this MVAC engine. 2 burns required to reach the targeted drop-off orbit for this IM-1 lander. And now the vehicle is coasting with payload attached, and we are just a couple of minutes away from spacecraft separation.
All right.
IM-1 could become the first U.S. lunar lander since Apollo's last landing in 1972, almost 50 years ago, and could be the first commercial lander to succeed in reaching the moon's surface. Again, we are just about a minute and a half, just under a minute and a half away from spacecraft separation. And on your screen, as we wait to get some live views, you can see on your bottom right-hand screen the speed and the altitude of the Stage 2 vehicle, again, still carrying the IM-1 spacecraft. And there's that live view there. Again, this is a view from the second stage vehicle looking aft at our MVAC engine there. We are patiently waiting spacecraft separation here, just under a minute from now. And now that we have this live, perfect timing, we've got this great live view of the IM-1 lander right before it begins its 8-day journey to the moon. This is such an incredible view and very exciting that we have spacecraft separation coming up here in just a few seconds.
IM-1, Odysseus lunar lander, separation confirmed.
And there we go. We have separation of IM-1. What a beautiful shot. Thank you to SpaceX.
What an incredible sight to see. The IM-1 Nova C lunar lander drifting away from Falcon 9's second stage, confirming spacecraft separation. From all of us here at SpaceX, we are wishing the IM-1 lander a great flight and safe travels. SpaceX is honored to be a part of NASA's Commercial Lunar Payload Services initiative to deliver science and technology to the lunar surface, and we thank NASA and Intuitive Machines for entrusting us with today's historic mission to the moon. For those of you following along, you'll know that this mission marks our 14th of the year and second just today. Congrats to the SpaceX team. We're just in February, and we've already launched in partnership with NASA missions like Axiom 3, Cygnus, and PACE. And we're gearing up for the Crew 8 mission before the end of the month. Check out spacex.com/launches for up-to-date missions and schedules. And before we sign off, let's go back to Josh at Intuitive Machines. Josh?
What an incredible, incredible view. Just a few moments ago, our flight controllers inside of Nova Control heard that confirmation of launch vehicle separation. This starts the countdown toward our lunar lander's autonomous commissioning. During this milestone, the lander is going through the steps required to power on, determine its position relative to the sun, and make communications contact with flight controllers in Nova Control. It's an autonomous process that takes several minutes. In that time, we'll walk you through what's happening in space approximately 200 223 kilometers or 139 miles from Earth. At launch vehicle separation, a spring force gently pushes Nova-C away from the launch vehicle's second stage. We just saw that, allowing the lander to deploy and drift away toward the moon. Brake wires connected to the launch vehicle let the lander know it has deployed, and Nova-C starts an internal timer to count down to when it's safe to turn on. After the timer finishes, Nova-C's primary systems are expected to autonomously power on. This includes guidance, navigation, and control, or GNC for short, automated flight management software, radios, sensors, and thermal control. The GNC system powers on the cold gas helium reaction control system to stabilize the vehicle's attitude, because at this point, the lander does not know where it's pointed, but it can stop any residual spin motion. This is much like a person spinning in a chair with closed eyes can stop spinning without knowing which way they're pointing when they stop. After controlling the spin rate, special cameras known as star trackers autonomously match images of the distant star field and provide Nova-C with its orientation. Software then takes those star tracker measurements and processes them through an algorithm known as the Kalman filter to correct the onboard orientation. The lander now has two critical data points: its attitude relative to the star field and a reference position from the estimated launch vector. With these data points, Nova-C may command its reaction control system to maneuver the lander's top deck solar array toward the sun for illumination, generating maximum power. All of these steps are expected to be happening right now, and when autonomous commissioning is complete, our Nova-C lander named Odysseus turns on its communication radios and makes first communications contact known as acquisition of signal, or AOS. Making that communications connection involves more than the lander's operations in space. It takes careful coordination here on Earth too, using Intuitive Machines' Lunar Data Network. The network was designed to support NASA's CLPS initiative, government services, and other commercial efforts using line-of-sight and data relay services for spacecraft in cislunar space, which also includes low Earth orbit. The secure network is made up of Nova Control, which we're keeping our eyes on right now, and strategically placed ground stations spread across the globe. The ground stations are expected to provide near continuous communications with Nova-C during the entire IM-1 mission. With that entire network available, our flight controllers responsible for communications and ground stations will be the first people in Nova Control to start seeing data from our lunar lander, which means the ground station assigned to this part of the mission has locked onto Odysseus's signal. Now, from the lander to Nova Control, all of these innovations and capabilities looking live into Nova Control.
SpaceX just deliver us.
Okay, copy. You're good to process in the background while we work contact.
Okay, I'll work with Fido on this.
Standing by. I don't see packets updating in packet counts unless I'm looking in AOS.
So we're still standing by for autonomous commissioning and making that first ground communication call to come from the COM or ground network stations inside of Nova Control. And this is Houston's first commanded lunar mission since Apollo 17.
All right, I see packets. And I see...
All right, guys.
And we have communication now.
We have it. We have packets. That is Michaela Landivar
All right, guys.
on the ground.
COM, I want your report. Uplink and downlink, what do we got?
Okay, so I am seeing packets populate on the AOS screen and in the packet counts area. Looks like telemetry is coming in pretty well. We have not started uplink, so we do not have uplink locks at this point. But it looks like we are seeing most everything that we would expect as far as
that's an
downlink
excellent call. We have reached a pivotal
Very good
milestone.
news.
We're going to bring it back into the broadcast booth and congratulate the team working inside of Nova Control as our Nova-C lunar lander has successfully separated from the second stage of the launch vehicle, autonomously commissioned, and made first communications contact with Nova Control. What an achievement for the entire Intuitive Machines team. Let's honor this momentous milestone and prepare for the challenges and triumphs that await us on our lunar journey. From Intuitive Machines' Nova Control in Houston, Texas, thank you for joining our portion of the IM-1 mission broadcast. We'll toss it back over to Megan in Florida for reaction to the successful launch of our IM mission. Megan.
Yeah, from here at NASA, we just want to say congrats to Josh and Intuitive Machines, another successful CLPS launch and orbital insertion of a commercial lunar lander. Now, hopes are high that a U.S. commercial lunar lander will make it to the moon. And joining me now to talk a little bit more about that and this program is Chris Culbert, and he is the CLPS program manager. Exciting to see this unfold right in front of us, huh?
Yeah, this is great. SpaceX gave them a wonderful ride, great launch, really clear sky. We could see it all the way up to the well, not to the moon, but on its way.
We saw the moon in the distance.
We could see the moon. It was a great launch. This is a great step. It's a lot of hard work to get here. This is 5 years of efforts from a very small company. But they've made a lot of progress. They solved a lot of problems, and now they're on their way. So this is a good start, but it isn't the end yet. They got to finish the next step.
That's right. But at least we have 8 days, right?
We do.
Have 8 days.
Yeah. So they've got 6 days to get to the moon, and then we'll hit the hard step.
Yeah, so with the challenge of landing on the lunar surface, what's your message to the Intuitive Machines?
So the big thing right now, they need to stay focused. Space is hard. Small mistakes can doom you. We know they're very talented. They're very well organized. We're really impressed with the depth and technical skills of this team, but you have to stay focused. You got to make sure you nail everything and stick the landing.
So again, a lot to look forward to, but we're optimistic.
Yes, we are. We're looking forward to it. I got a lot of faith in these guys.
Great. Chris, thank you so much. Glad to be here with you again for another CLPS launch.
Thank you very much.
Okay, so that is going to wrap up NASA, Intuitive Machines, and SpaceX coverage of the launch of the Nova-C moon lander on a SpaceX Falcon 9 rocket from Pad 39A here at Kennedy Space Center. Again, if all goes well, Nova-C is expected to land on the moon 8 days from now, so mark your calendars, on February 22nd. It would be the first U.S. landing on the moon since 1972. We'll, of course, bring you that coverage live right here on NASA TV. And until then, you can find out more about this mission and other NASA CLPS launches by going to the link we're about to show on the screen here, nasa.gov/CLPS. We're going to leave you now with a replay of today's launch for everyone here at NASA, Intuitive Machines, and SpaceX. I'm Megan Cruz, and have a great morning.
15 seconds. Four, 3, 2, 1, ignition, and liftoff. Go SpaceX, go IM-1 and the Odysseus lunar lander.
Vehicle pitching downrange. Stage 1 propulsion is nominal.
Falcon 9 has successfully lifted off from Pad 39A at Kennedy Space Center, carrying the IM-1 payload. Now, during ascent, we tilt the engines, the technical term being gimbaling, and that turns the rocket horizontally. And
Okay, folks. And with that, we've had a very successful launch. We've had stage separation. We've had separation of the vehicle Odysseus. And we've also just saw that we had telemetry and downlink being received. So the autonomous commissioning of Odysseus went without a hitch. They're now will be in the process of trying to upload and get their uplink connected and all that. But as was indicated, space is hard. Getting to the moon is hard, and they've got a long way to go. But a great start. We had an awesome launch, landing of the first stage. That was recovered. We didn't get to see all of that. Be interesting to see if there was anything going on there. But short of that, very successful day. Didn't result in 3 launches today for SpaceX, but 2, and one of them was moved. That would be the Starlink launch out of Vandenberg, was moved to tomorrow. So we'll try to bring that to you when that is scheduled. So at this point, we will call it a stream. Thank you for coming out, middle of the morning, middle of the night. Very exciting day and exciting mission. We'll keep a close eye on it. bring updates. If you have any questions, any comments, please feel free to leave them. I will get back to you with anything that I can answer, anything that we can do as far as the broadcasts go. If you're a subscriber, again, thank you so much. We appreciate all the subscribers, all the likes, all the shares. They all help with YouTube getting us out further and further and getting us into more viewing and more ability for people to see our channel. And that's what it's all about. We want to bring as much of this, these educational opportunities as we possibly can. Thank you to SpaceX. Thank you to Innovative Machines. And thank you, of course, to NASA for providing the feeds, providing all those amazing camera views, and the commentary that went along with it. It's a great opportunity for all of us to experience the initial stages, the very beginnings of the beginning of return to the moon for the second time. With that, I'm Papa D. This is David Delivers Space, and we'll see you at the next launch. Have a good night.